So how will you find a relationship between the pressure and volume for an adiabatic process? For that, let's take the first law of thermodynamics. We have the heat supplied to a system is used for two processes. First one to increase the internal energy, that is dU, plus then to do the work. This dU means the increase in internal energy, dW means the work done, and dQ means the heat supply. But the increase in internal energy is always number of moles times molar specific heat capacity at constant volume times the rise in temperature. But for 1 mole, for n equal to 1, that is 1 mole, we have du is equal to Cv dt. Let's substitute the value of du in here. That is dq is equal to Cv dt plus the work done will always be pressure times change in volume. Let's call this as equation number 1. Before that, we have for an adiabatic process dq is equal to 0 because no heat is transferred or taken from the system for an adiabatic process. For adiabatic process. Therefore, you can write Cv dt plus Pdv equal to 0. Let's call that as equation number 1. And for the ideal gas equation is Pv equal to nRT or Pv equal to RT for 1 mole of a gas for n equal to 1. If you differentiate the equation, that is d of Pv equal to d of derivative of RT. You can write this as P. You can use the product rule of derivatives, that is first function P into derivative of second function plus second function into derivative of first function equal to, here the R remains constant, so R dt. Therefore, dt will be, dt taking this R to the left, P dV plus V dP divided by R. Let's call that as equation number 2. Now you can plug in the value of dt in here. Okay, that is substitute equation number 2 in 1. You will get Cv times, instead of dt you can write this P dV plus V dP divided by R plus P dV equal to 0. Okay, now let's simplify this equation. That is Cv, this will be Cv P dV plus Cv V dP whole divided by R plus P dV equal to 0. Now you can multiply the whole equation with R. So if you multiply R in R, the first term, you can also multiply R with the second term. Okay, also R on the right side. If you multiply whole terms with R, you will get this R and this R will get cancelled. So Cv P dV plus Cv V dP plus Rp dV equal to 0 into R is again 0. Let's call this as equation number 3. What if you divide the 3 with the term PV, pressure times volume? So this will be Cv P dV by PV, divide each term with PV. Cv V dP by PV plus Rp by PV dV equal to 0. Therefore, this will become, you can cancel a P and a P. Here also you can cancel a V. Here the pressure will get cancelled. So the final equation will be Cv into 1 by V dV plus Cv into 1 by P dP plus R by V dV equal to 0. Okay. Now you can assemble this dV terms. There is a dV in here. Also there is dV. So you can write, let's first write this Cv 1 by P dP plus, take this 1 by V Cv as common. So 1 by V dV as common. So 1 by V dV times, there is Cv plus here it is R equal to 0. But you know from Mayer's relation, Cv plus R equal to, Cp minus Cv equal to R implies, this is called the Mayer's relation. So Cp will be Cv plus R. So here you can plug in the value Cp. So Cv into 1 by P dP plus 1 by V dV into, here it is, Cp equal to 0. Now divide the whole equation. Let's divide the whole equation with the Cv. Let's call this as equation number 4. Let's divide equation 4 with the Cv. You'll get here Cv by Cv into 1 by P dP plus 1 by V dV into Cp by Cv equal to 0. Cv by Cv will get cancelled. So this is equal to 1 by P dP plus, you can write this term as the heat capacity ratio. Cp by Cv is equal to heat capacity ratio, gamma. So you can write it in here, gamma times then 1 by V dV equal to 0. Let's call this as equation number 5. Now you can integrate the equation 5. If you integrate the equation 5, what you get? Let's see. Integral 1 by P dP plus integral gamma times 1 by V dV equal to integral 0. 1 by P dV is equal to log P plus, you can take this gamma out, gamma into 1 by V dV is log V equal to integral of 0 is a constant. Okay, you can take this gamma to the power of V, since you have a log V is equal to log V raised to A. Similarly, here it will be log P plus log V raised to gamma equal to C. Also, log A plus log B equal to log AB. Therefore, this will be log P into V raised to gamma equal to C. Now, if you remove the value of log, you can write this in the exponential form. Here there is an E. So, P V raised to gamma will be E raised to C. You have log A to the base B equal to C, then A raised to C equal to B. Clear? Similarly, E raised to C is equal to PV raised to gamma. But E is already a constant, C again is a constant. So, PV raised to gamma equal to K, a constant. So, PV raised to gamma equal to K is the adiabatic expression for the pressure and volume. You can also write P1 V1 gamma is equal to P2 V2 gamma.